I'll make sure to record now, and you should probably have gotten a message to allow it to be recorded. All right, so can everybody please turn your videos on to make sure that you're present? So it looks most people have shown up at this point. So yeah, I guess I'll just get started. So to start, I'll be reviewing a couple homework problems that I noticed um, a lot of, or quite a few people got wrong at least. But if anybody has any more like other homework problems that they want to be done, then you can just private message me, and I'll try to go over those two. Homework problems I'll be going over are problems 6, 9, and 10, and we'll pull them up on my computer and my slides. Just take a minute. So start off with the homework review. I'm assuming that most of you have already done it. So to start off, I have question 6. The problem statement is a ball is dropped from a height of 3 meters. On its first bounce, it rises. Sorry. On its first bounces rises to a height of 2 meters. It keeps falling and bouncing to a height of 2/3 of what it reached in the previous bounce. And on which bounce will it not rise to a height of 0.5? So you have a ball bounces up to 2/3 of previous bounce, 2 meters, keeps bouncing. Then it's asking you, when will it, at what point will it will this height be less than 0.5, basically? Now, does anybody have any ideas on how to solve this problem? You can just unmute. Right, I see Leo has raised his hand. You can go ahead.
I just kept multiplying every single bounce by 2/3 until I get something that's less than half.
And yeah, that should basically be the way you do it. You just keep on multiplying it by 2/3 each time. It's exponential. 2/3 to some power. Although, to be careful not to be like off by 1 or anything, remember that bounce 1 is 3 meters. So that's like your reference point, I guess. And then bounce 2 is 2 meters. And then 2, and then the next one would be 4/3, and 8/9, I believe, and then 16/27, and it's still bigger than a half at this point. On the next bounce, 32/81, it is no longer above half. And so then I think if you count that, the and, oh no, sorry, this is not first bounce. This is the height it was dropped from, and this is the first bounce actually. So that would be a total of 1, 2, 3, 5 bounces. And yeah, just be careful about this is not bounce number one. This is like this zeroth bounce or the height which it was dropped from. I'm not really sure exactly what mistake people made, but yeah, that is one potential place where you can make the error. And so the next problem for homework that I'll go over is problem 9. Number 9 is asking how many positive integer values of n are there such that both n over 3 and 3 in 3-digit whole numbers. So to start off, can somebody tell me like what this condition means? Like, how can we express that the restriction that they both have to be 3-digit numbers? All right, so someone sent me the answer, but they're going over the solutions. And so can someone tell me what the condition is for both of these numbers to be 3-digit numbers? Just raise your hand or unmute if you want to say something. All right, I guess no one is willing to volunteer for this one. So for this, for it to be 3-digit, this has to be less than or equal to, both of these have to be greater than or equal to 100 and less than or equal to 999. And yeah, so we have n over 3 is a smaller one. So like, um, we don't need to check 3 and is greater than or equal to 100, because if n over 3 is greater than or equal to 100, then 3 n will be, of course, as well. And similarly for the upper bound, we just need to check if 3n is less than or equal to 999, because if 3n is less than or equal to 999, then n over 3 will be, of course. And if you solve this, you get n is greater than or equal to 300, and then this one gives n equal less than or equal to 333. Now I see a common error that some people make is that they'll think that it's just anything from 300 to 333 works. But if you read the problem, it asks you how many integer values of n are there such that both of these numbers will be 3-digit integers. And the key is that they have to be 3-digit integers, both 3n and more importantly this n divided by 3, and that like not all values in this range will make n over 3 an integer, only those divisible by 3. Like 301 won't work. Yeah. So if you count those, that should be 333 minus 300 over 3 plus 1. And that should be an answer of 12, if I remember correctly. And yeah, the most common mistake was just you have to make sure that it fits the original condition that makes this a 3-digit integer, because I saw a lot of people pick 34, or like quite a few people pick 34 at least, which is the common pitfall for this. And yeah, that's the main thing I wanted to point out in this problem. And just to check, am I echoing from the iPad? If I am, sorry about that, and I'll go. Sorry. I'm sorry about that. My Wi-Fi just cut out for a second. All right, now for question 10. So let me see. Question 10 is 10 tiles are numbered 1 through 10. 1 through 10. They are all turned face down, and so you can't see the numbers. One of them is turned face up at random. And then it's asking you, sorry, this is not loading well. And it's asking you, what's the probability that the product of the numbers on the tile and the die, or one tile is turned up at random, sorry, one of these tiles with numbers 1 to 10, and a die with a just standard die with numbers 1 to 6 is rolled. It's asking you, what is the probability that the product of the numbers on the tile and the die will be a square? So a perfect square, that means like it can be written as the product of two numbers that are the same, of course, like 4 times 4. And alright, is somebody saying that I'm glitching or cutting out really badly? Can everybody hear me alright? Test. Alright, it's better now. Okay, that's good.
Better. Yeah,
Alright, so I'll continue. So you have 10 tiles, numbers 1 to 10, a die with 6 sides, and like everything happens with equal probability, and then you want to find out what's the probability that the product of the two numbers you get by flipping one tile randomly and rolling the die will be a perfect square. And so, does anybody want to share their idea for this? You can just raise your hand or talk out if you have anything. All right, so Christine is raising her hand. You can go ahead, unmute and go ahead.
There's 60 chances because 10 times 6 is 60, and then you just count the squares up to 60. So 1, 4, 16, 25, 36, 49.
And yeah, those are all the squares that are less than 60, which is the maximum product you can obtain. And so then you want to see what's the probability that you get each of these. For one, there is only one way to do it, to get it, is that you get, oh yeah, sorry, I forgot 36. There's only one way to get 1, that's 1 times 1. So there's one way for 1. For 4, you can have 2 times 2, or 4 times 1, 1 times 4, either way. Oh no, on 1 times 4, you can swap, you can have the die get 4, or the card be 1, or the other way around. So that's 2 plus 1 is 3. For 9, you only have 2 options now because you can have 3 squared, or you can also have 9 from the tile and 1 from the die, but not the other way around. So that's 2. For 16, you can have 4 squared only one way, or because 16 is out of the range of both the tiles and the die. And for 25, you can also have only one way, similarly to 36, that for 5 squared.
For 16, can't you do 8 times 2?
All right, sorry, yeah, I forgot about that. For 16, there are two ways to do it. 8 times 2 from the other from the tile you get 8, and from the dice you get 2. And from 36, I believe there are also 2 ways, 9 times 4, and then 6 squared. And for 49, you can't get it since the smallest number you need is 7. That's 7, and you need 7 squared for that. So there are no ways to get 49. Alright, so then the total possible number of combinations of numbers you can get, that will success is 1 plus 3 plus 2 plus 2 plus 1 plus 2 is equal to 11, I believe. And then that divided by 60, which as mentioned before was written here as the total number of different pairs you can get, should be the answer. And you just have to be really careful with this, I guess, because you can easily miss something. I just missed 16 is 8 times 2. And so these numbers are pretty small, so you can just write out all their factorizations, I guess, if you really want to. To just to make sure that you get everything in. And so yeah, that's basically it. Nothing too fancy about this. Now, does anybody have any more homework problems that they want to go over, or are you okay with going over what I have for today? Alright, I guess nobody wants to go over any more homework problems, so I will switch into the material I have to cover today in just a minute. Alright, so for today's topic is mainly algebra related, dealing with variables as well as equations like speed, rate, and time formulas, and also a bit of equations of lines. Okay. So to start off with, a variable represents an unknown quantity, often one that you want to solve for. And an important skill is to assign a convenient variable to solve your equation or problem you want to solve. So for example, we're given Angela is 3 years older than twice her brother Thomas's age, and if she is 17, how old is Thomas? And so can someone tell me what's the variable that you want to assign? Don't jump to the answer straight away just yet. We want to make sure that you know how to use the right variables to solve this. Alright, so I've gotten a couple of suggestions. Yeah. Alright, so these are all right so far. So I see Nathan at the top of my screen, so can you unmute and say what you think the variable should be?
Honestly, the variable could be anything you could represent it by a letter.
Yeah, that's right. Letters usually represent variables, but what does the variable represent? What quantity does it represent in this problem?
It's basically representing Thomas's age.
Yeah, that's right. To represent Thomas's age, I think it'll make sense to use t or something like that. And so we can write an equation based on this. We have the information we're given is Angela is 3 years older than twice her brother Thomas's age. So first we have twice of Thomas's age, and then we add 3 more to that. And then we're also given that Angela is 17 years old. And so now, as many of you probably did, maybe mentally even, you can quickly solve this to get 2t is equal to 14 and t is equal to 7. So Thomas should be 7 years old right now when Angela's 17. And yeah, this is a very, I guess, simple application of variables. It's just you set the variable to what you want to solve for, and then you can solve for it relatively simply. Sometimes you may not always want to set a variable to the final quantity you're solving for various reasons. But in those cases, always make sure that the final answer you put down is not the value of the variable, but rather what they're asking for. All right, so next example, for consecutive integers. This one, just be careful. If you assign like a variable that's more convenient to solve for as an intermediate step, just make sure you like answer the final question at the end. So we have the sum of 5 consecutive integers is 80, and it's asking you for what the smallest of these integers is. And does anyone have ideas for this? I think there are multiple different ways you can go. They're pretty similar, but yeah. All right, so I see Vincent is raising his hand. Do you want to give your ideas?
So we have the sum of 5 consecutive integers is 80. So so we're trying to find for the smallest of these integers. We can have this as x. And then we have the equation 5x plus 10 equals 80. So 5x equals 70. And then 70 over 5 equals 14. So x equals 14.
Yeah, that's right. So you jumped a little to 5x plus 10, but yeah, to get 5x plus 10, you notice that x is the least, and the other 4 integers should be x plus 1, x plus 2, x plus 3, and x plus 4. And then you add those all up, and then you get 5x plus 10, and that you're given is equal to 80. So you just directly solve for x. Like you said, 5x is equal to 70, and this x is equal to 14. Should be. Does anybody have a little bit of a different way of going about this? It's all right. So I see who's at the top of my screen. Is that Matthew C? All right, you can go ahead.
Oh, wait, sorry, I forgot to put it down.
Oh, all right. Okay. So the next person I see is Jerry. You can unmute and speak.
Okay, so typically what I did is what I do 80 divided by 5 because there's 5 consecutive integers, and then I just subtract 2, which gives me 14.
Or yeah, basically, I think that is the other way to go around, is to pick like the center number as the variable, especially when there's an odd number of consecutive integers. That's very convenient, because if you have all right, sorry, whoops. If you have the middle number as your variable, say x again, although it's a different x, then and you have a number 5 consecutive, it's just 5x is equal to 80. So then you have x is equal to 16. But be careful, don't just like put down 16 once you get that. As you said, you have to subtract 2, because the least number is 1, 2 to the left of 16, of the middle one, 16. So yeah, that's your answer. That's another way of doing it. It's a bit like for even numbers, you can pick one of the 2 middle ones, or maybe even the average if you want to go that far. But yeah, like oftentimes setting it as like the midpoint or some other convenient number that lets all the other things cancel out, because you get x minus 2 plus x minus 1 plus x plus 2. is x plus 1 will often save you some time, but just be careful to answer the final question that they're asking for properly in these cases. All right, so for next problem is, I guess, special, kind of like an application of variables and different formulas. And for the key formulas, I'm sure many of you already know, is for a rectangle, its perimeter is 2 times the sum of its length plus the width, and its area is the length times the width. As an example problem, the height of a rectangle is 3 centimeters more than twice its length. If the perimeter of the rectangle is 60 centimeters, what's its area? And so does anybody want to start off this one with defining variables, writing equations? You can just raise your hand or unmute if you want.
Who is? You. Icy hot.
All right, can you please mute yourself, whoever's doing that. All right, okay. So I see Vincent and Jerry raising their hands. I usually prefer to let other people answer, but sure, for this time, Vincent, you can go ahead.
So the height of a rectangle is 3 centimeters more than twice its length. So let's have the length equals L. So the height is equal to 2L plus 3. And then 2L plus 3 plus L equals 3L plus 3. Times that by 2, 6L plus 6 equals 60. And then divide by 6L plus.
All right, I think he's cutting out a bit for me. I'm not too sure if that's my end
The height
or his.
is 189.
All right, so I heard Sorry about that. My Wi-Fi hasn't been very well today, so I might get thrown out a few more times. If that does happen, you can just sit tight, and I'll probably be back in a minute or two. In that case. All right. So as I heard Vincent saying, you have that height is 3 centimeters more than twice its length. So the variables, I'd say, are h and l. And then we have h is equal to 2l plus 3. And then he said he used the perimeter formula to get 2 times h plus l, which is equal to 2 times 2l plus 3 plus l is equal to 60. And then, as he said, 6l plus 60 plus 6 is equal to 60. So then you get l plus 1 is equal to 10, and then l is equal to 9. And the h would be equal to 2 times 9 plus 3, which is equal to 21, and thus the answer would be 21 times 9 for the area is equal to 189. And I see someone asking me, can't you just do 60 halves is 30, and then 30 minus 3 is 27, and then you get the width and length from there? And yeah, that's another way of doing it, although it's a bit different, and it doesn't, or like the way you wrote it doesn't really use variables that much, which was what I was trying to teach about. But yeah, you could do L plus W is equal to 30, and then you just conveniently get rid of all the constants. You get rid of this 3 once you plug it in, and you get like 3L is equal to 30 minus 30, and then yeah, you just solve for the other ones like that. And yeah, that's another way of doing it. And yeah, the answer is 189, 21 times 9. And so yeah, that's this problem. I'm sure many of you already knew the area and parameter formulas for rectangles already, but yeah, just to cover it and reinforce it again. There will be other geometric shape formulas and other formulas for different kinds of problems here too. Okay, and moving on, we have the distance, speed, and time equation. We have distance equals speed times time, or rate times time. That's why R is used. And you have speed or rate equals distance divided by time, and then time is distance divided by rate. For an example, we have this person, Marlon, jogs 2 miles to the park in 25 minutes, turns around and takes another 55 minutes to walk to the same path back to his house. What's his average speed for the round trip? All right, and I think since it's on here, I should also mention that average speed is not just averaging two different speeds. It is the total distance that he traveled in all his time over the total time. And so given this, can anybody walk through solving it? All right, so I see Vincent, you've already gone twice. I see Matthew. Matthew, you can go ahead.
So total distance is 4 miles since it's 2 miles to the park
Right.
and 2 miles back. So it's 4 over total time, which is 25 minutes plus 55 minutes, which is a total of 70 minutes. So it's 4 over 70 miles per hour.
Actually, it's 4 over 80, and you just added 25 and 55, a bit off. And so yeah, just always be careful of this in general. Math competitions, try not to make little mistakes, and always check your work. And so yeah, the answer should be 1 over 20 miles per minute, or if you want to convert that, 3 miles per hour is his average speed. Again, average speed is not just averaging 2 over 25 plus 2 over 55. It's not what it is. It's actually something different called the harmonic mean of two speeds. Which I believe is mentioned later in the slide. I'll get to that later. And so we have another problem with average speed. On a bike ride, Calvin starts at home and goes up a long hill for 30 minutes at just 6 miles per hour. And at the top, he turns around and rides home along the same path at a speed of 18 miles per hour. And they want to know, what's his average speed for the round trip? All right, now does anybody want to take a crack at this? This time I believe we are not given the length of the hill, but can you still do it? All right, I see Christine is raising her hand, so you can unmute and go ahead.
So it says it's 30 minutes for 6 miles. 6 miles divided by 2 is 3 miles. So the hill itself is 3 miles, and then and then he turns down and rides at 18 miles per hour. And since it's only 3 miles, 18 divided by 3 is 18, or 3 is 1/6 of 18. So 1/6 of 60 minutes is 10 minutes. So it took him 40 minutes to go up and down because 30 plus 10 is 40. And then 40, so then he went 6 miles. So
All right, I think she mistook this 6 miles per hour as maybe it was kind of hard to follow what she was saying. But I think, and she was saying that 30 minutes times, or 30 minutes, which is equal to half an hour. You first have to do that because you want to make sure they're the same units, half an hour. So half an hour times 6 miles per hour is equal to 3 miles. And then she rides down those 3 miles at a speed of 18 miles per hour. So basically for this it's just d equals rt on the separate branches of his journey at the speed of 18 miles per hour. So 3 miles over 18 mph is equal to 1/10 of an hour, which is equal to 6 minutes. Sorry. All right. So in total, or no, not sorry, no, I messed it up. It's 1/6 of an hour, which is 10 minutes. 10 minutes. All right. Let me erase that and write it again. So yeah, as I heard her say that in total, the journey took 40 minutes, which is correct. 40 minutes is 2/3 hours. 20 minutes is 1/3 of an hour. Yeah. And then her total distance is just 3 on the way up, 3 on the way down. 2 times 3. So yeah, that would be 9. I believe, yeah, 9 as someone has just sent me. 9 miles per hour is her average speed. And yeah, that's another problem. And yeah, that's another problem about average speed, and also applying distance equals rate times time to get the quantities if you want, the quantities that you want. All right. Moving on, as the slide said, I was about to get to, average speed doesn't actually depend on like what the exact distance is. Like for our previous problem, we could solve for the distance traveled as 3 miles, but if we weren't given that, we could still solve for it as long as the distance up and down we knew their relative like quantity, like if they were the same or whether it's twice as much on the way up and twice as much distance covered on the way up as the way down is on the way down. And so we will look at that in this problem. So one strategy is mentioned here so that you can just like take a number for the total distance, or in this case work done, that's convenient to fit the other numbers in the problem. And so the problem is the water from the swimming pool evaporates at a rate of 6 gallons per hour in the shade and 19 gallons per hour in the sun. And the amount of water lost to evaporation in the shade is equal to the amount lost in the sun. So it wants to find what's the average rate of evaporation from the pool. And does anybody have an answer or a way to do it for this? Someone who hasn't gone yet, maybe? You can just raise your hand or unmute if you have anything. Alright, so I don't see anybody yet. So in this case, a convenient amount to pick for the water loss and evaporation, since we're not given what that number is, we just know that the amount lost to evaporation in the shade is equal to the amount lost in the sun. It's equal. And so since we know one rate of loss in the shade is in 6 gallons per hour, the other is 19, we could just take like 6 times 19, which happens to be their LCM as well. And 6 times 19 lost both periods of time. So then it would be the total time would be 6 times 19 gallons over 6 plus 6 times 19 over 19, which is conveniently just 6 plus 19, which is 25. That should be 25 hours total. And so then we have, going back to what we want to find, average speed, total amount of gallons lost is 2 times 6 times 19, then divided by the total time of 25 hours. So then that would be 228 over 25. which I believe if you convert that into decimals should be like 9.12 gallons per hour or something. And yeah, I believe that's how you do this. Again, you can actually just set a variable d to be the amount lost both times, and you get 2d for d over 6 plus d over 19, and you can see that these will cancel, so it's really just 2 over 1/6 plus 1/19th, and that should give you the same thing. All right. And so moving on, as I mentioned earlier when I was hinting, the average speed doesn't actually depend on the distance if we know that the distance or the work done is equal for both speeds. You can have if you have the speeds A and B, then if you do it using distance equals rate times time, the total distance is 2d if d is the distance traveled in both legs. Then you have d over a is the time for one part, and d over b is the time in another part. And then you just cancel these d's, so you get 2 over a plus b over ab if you combine this fraction. So it's 2ab over a plus b, and this is known as the harmonic mean. And you'll notice that we can apply this to our previous problem back on this slide. We have 2 times the product of the rates, 6 times 19, or 6 plus 19, which is 228 over 25 again. And yeah, this formula is known as the harmonic mean, at least of two numbers. You'll probably run into it again later, but yeah, for now, this is the main application of it, or the main place where it comes up. Alright, so now that we've gone over average speed and basic distance equals rate times time, we'll look at a variation for it, but this time we throw in like how many people are doing the work. So it takes 7 minutes for 7 moles to dig 7 holes. And you want to find out how long will it take 8 moles to dig 8 holes. And assume that all the moles work at the same rate, so that like if you have 2 moles as opposed to 1, they'll do twice the work. Alright, so does anybody have any ideas on how to solve this problem? How to set variables and solve this problem? Alright, so I see Ethan, I believe, has sent me a correct answer to this problem. Would you like to go ahead and explain how you got that?
With 8 moles digging on 8 holes, it's easiest to assign each of them to dig 1 hole. If 1 mole takes one hole, if it takes 1 mole to dig 1 hole for 7 minutes, they all work at the same pace and at the same time, so it would just be the same 7 minutes.
Yeah, that's right. And that's what's kind of deceptive about this problem. Is that you'd see 8 moles digging 8 holes. You see 7, 7, 7 here, but it's actually still 7 minutes. And why that is? Because the amount of work they have to do is 8 holes instead of 7. So that should take them 8 over 7 times as long, because that's the factor of increase for the work done. But there are 8 moles as well. And so 8 moles means they work 8/7 times as fast. So it would take them only 7/8 amount of time for 7 moles doing the same amount of work. So you combine those two together, they cancel out just to become 1. And so the time actually remains constant for this compared to 7 moles and 7 holes. And just like Ethan thought about it too, like it's really just like the amount of work being done and the amount of workers staying proportional to each other. It's 1-to-1. So, and it's just 1-to-1. It's the same for both, so the time shouldn't be any different. And I believe, and yeah, that's all there is for this. I believe on the next slide there's a formula incorporating the amount of workers.
I have another solution for.
All right, so Matthew has another solution, and you can go ahead.
So each mole's work rate per minute is 1/x. So in the 7-minute case, there's 7. So their work rate is 1/7 whole per minute. So basically do the same thing with the 8. So you do 1/8 per minute, and times the number of moles, which is 8, and you get 8.
All right, so yeah, Matthew was just saying first, like, I believe he was saying first look at 1 mole's work rate, and then 1 mole's work rate for 1 hole, and then change, and then see how long it'll take for 7 holes, and then incorporate the factor of 7 and 7 to get this time. And then for 8 and 8, it just turns out being the same because of, like, as I showed the cancellation earlier with the amounts of moles and the amounts of holes increasing by the same amount. All right. So on the next slide, here we're asking you to create a formula for these problems, given the number of actions, and given, because we know the number of actions done is proportional to the amount of objects doing the work and the amount of time, and then the rate can be transferred to a different number of objects and a different number of times and different amount of time. So an example of this is 5 moles dig 4 holes in 3 minutes. How long does it take 9 to dig 6 holes? Alright, so can assign maybe the work done is equal to, we can assign the work done is equal to the rate at in which they work times the time, but then the rate, of course, is proportional to the amount of moles there are. The amount of moles in this case there are. So yeah, this is really 5 times the rate of 1 mole. And 5 times, and then here it's 9 times the rate of 1 mole. And so for this, if you don't like straight away see what the answer is with like all the multiplying of the ratios, you can just say, oh, R is the weight of 1 mole. There are 5 moles, so it's 5R, and then times 3 minutes is equal to 4 holes. Sorry, it's a bit messy. Times 4 holes. And then you want to see how long does it take for 9 moles to dig 4 holes. So first of all, we have R is equal to 4/15 for 1 mole. So 9 moles, the rate would be 9R. And then times the time T would be equal to 6 holes. So then T would be 6/9R, which is 2/3R, which is 2/3 times 4, 15, 2/4, which is equal to 5/2 minutes. And yeah, I got that as an answer from someone, and good, that's right. And so yeah, just make sure to remember, increasing the amount of workers makes the work rate increase, whereas increasing the amount of work done just makes the work increase proportionally. And increasing the amount of workers makes the time decrease, whereas increasing the amount of work you have to do makes the time increase by that proportional amount. And yeah, just be careful of that. Don't be fooled by like the 7 and you see the 8 moles and 8 holes and then answer 8 for that. And so here's some more practice for that. So it takes 6 lumberjacks 7 minutes to saw through 8 trees. How many minutes will it take for 7 lumberjacks to saw through 8 trees? And the second problem, Franklin rides his bicycle to the beach while averaging 18 miles per hour, and he rides home along the same route. And what speed must he average on the way home if he wants to average 21 miles per hour for the round trip? All right, so number 2 is more of an average speed problem. Number 1 is about what we just talked about, like the amount of work and the rate of multiple people doing it at the same time. And so I'll give people a couple minutes to solve these problems. And yeah, just if you have an answer, just send it to me and I'll tell you whether or not it's right. Right, so I've seen a couple of answers for number 1 so far, but none for number 2, so maybe I'll give you 6 more minutes for both of these. All right, so I see some people have attempted number 2, but most people thought that average speed was the average of the 2 speeds, and it is not, as I covered it earlier. And so I'll give people a little bit more time to think about it and see if anybody gets it. All right, so I think it's a good time to go over them now. So I see a lot of people, or quite a few people at least, have gotten number 1 right. So, Leo, do you want to explain number 1?
So it takes 6 lumberjacks 7 minutes to saw through 8 trees. So if you were to get that 6 lumberjacks and turn it into 1 lumberjack, you'd get it takes 1 lumberjack 42 minutes to saw through 8 trees. So if you multiply that back by 7, you'll get 7 lumberjacks take 6 minutes to saw through 8 trees.
Yeah, that's right. So I think, yeah. So as he said, you can just if you can't like do it all in one step. First, you find how long does it take for 1 lumberjack to do it, since the only thing that's changing here is the amount of lumberjacks there are. So for 1 lumberjack, it'll take them 6 times as long, since they work 1/6 as fast. So it'll take 7 times 6 is 42 minutes. And as he said, 42 minutes divided by 7, since 7 lumberjacks work 7 times as fast, and thus would take 1/7 amount of time. It will take them 6 minutes to saw through the same amount of trees, or 8. And all right, so yeah, that's the approach. That's the rough approach for number 1. There are some slightly different ways, some slightly different order of steps you can take to solve it. But yeah, number 1, the answer is 6 minutes, and that's the explanation for it. And Does anybody have number 2 yet? All right, so I'll go over number 2 then, I guess. So we have Franklin rides his bicycle to the beach, averaging 18 miles per hour. He rides home along the same route, meaning his distance to and from at his two different speeds are the same. And you want to find what speed must he average on the way home. And so that his average speed for the whole journey is 21 miles per hour. And I see that reading this, you might be a bit misled because first, the speed he must average on the way home, and you have this average 21 for the whole round trip. But as I covered earlier, average speed is not the average of the two speeds, which was a common mistake I saw. And you just have to detach yourself from the instinct that average is just like taking two numbers, adding them, and dividing them by 2. And so, as I covered earlier, for average speed is the total distance over total time. And I believe somebody actually just sent me the right answer. Ethan. So do you want to explain number 2?
I use the harmonic mean to AB divided by A plus B. We already know A equals 18, so 2 times 18 is 36. 36B over 18 plus B equals 21, which equals 25.2.
Yeah, that's right. That's the way I just did it. I did it just now to check. So, he said that the average speed is equal to the harmonic mean of the speed to and from. If A is if the A is one of the speeds, B is the other speed. Doesn't really matter which order actually, as long as the same distance is covered. So you know that on the way there it's 18. So the expression for the harmonic mean just becomes, you can write it in terms of the speed on the way back. And we want this to equal 21. So then you just multiply by 18 plus b on both sides. 36b is equal to 21b plus 21 times 18. I forgot to cancel a factor of 3, so I'll do that now. 12b is equal to 7b plus 21 times 6, which is 126. 126, sorry about that. Okay. And then you get 5b is equal to 126. And that gives you b is equal to 25.2. And here I think Ethan just directly applied the harmonic mean, knowing that. But if you want to if you're having trouble on differentiating average speed from just the average of two speeds, it'll probably be better to go back to the formula. And probably be better to go back to the formula for average speed as total distance over total time. Even though you're not given the distance, you can just set a variable for it as d maybe, and then 2d, and then the total time is the sum of the time you have to split it into the two different legs of the journey. As d over 18 plus d over the rate on the way back, and then you just get the same harmonic mean expression that he used. And yeah, you solve for it and you get 126 over 5 or 25.2. And so I got a question in the chat, why did I use rate instead of time for the first problem? And well, I used the change in the rate because 6 lumberjacks and 7, and from 6 lumberjacks to 7, that was the rate changed. The rate changed because the number of lumberjacks changed instead of the time that was changing. He said, you meant question 2. So what speed must he average on the way back? So the harmonic mean is actually, it turns out to be the two different rates in terms of the two different rates, because if you see, like, it's the total distance. If you start from this raw expression, this is the total distance on the top, 2d, and then d over a plus d over b are the two times, and where a and b are the rates. And then you just see that, and if you move the terms from the denominator into the top and cancel out the d, it's only in terms of the rates actually. So yeah, just remember the harmonic mean. These quantities a and b are the rates, are the two different rates for the journey. And so yeah, that's why it's rates, because of the way everything cancels. And yeah. And how did I cancel out d? So it's a bit like confusing because it's like complex fractions, but it's 2 times, there's a factor of d here on the top, and then the denominator is really just d times 1 divided by a plus 1 divided by b. So you see there's a factor of d on the top and the bottom, and you cancel them out. Is that clear? All right. I think, yeah, that's all there is. And it's 2 over 1 over a plus 1 over b. Be careful with this. 1 over a plus 1 over b is equal to a plus b over ab. It's not a plus b. All right, and if you have any additional questions, you can ask me later, maybe after class, but I will move on to the next part of the lesson. So now we will move on to lines. And so for definition, the simplest equations of lines in the xy plane, or as you're probably also familiar maybe with it, the Cartesian plane, can be reduced to the slope-intercept form, which is probably the form that you've seen up to this point. It's the y is equal to m times x plus b, and where m is the slope of the line, or the quantity that represents the slope here, and then b is how high up this is the y-intercept. And if graphed, y is the vertical coordinate part and x is the horizontal, and it creates a straight line. For example, here we have y is 1/2 x plus 4. Since the y-intercept intersects the y-axis here at 0, 4, at the point 0, 4, and then the rise is 2, or if you just, or actually you can just take slope as you take two integer points because those are convenient for you to calculate and measure with. You see that the x increase, for each increase of x by 2, the y coordinate increases by 1. So then the slope would be the ratio of the y change to the x change, which is 1/2. So that is how you get 1/2 x plus 4. And slope-intercept form is probably the simplest, most straightforward form to use, since all you need is the slope of the line and the y-intercept, and then that's the form of the line you have. And yeah, that's slope-intercept form. We'll see some examples of it. And yeah, this is basically what I covered. Rise over 1 is the vertical change divided by the horizontal change. Notice that this could be negative if like the vertical change is negative while the horizontal change is positive. And the meaning of negative slopes less than 1 means like the line is going down. Oops, that was a bad line. Line's going down. When the x increases, the y goes down in this direction. And the class time is almost up. But so just one quick last question before you go. What's the slope of the line that passes through 7, -2, and -4, -1? Does anybody want to do this really quickly? I don't see a correct answer yet, so I'll just do this quickly. So it's from 7, or actually, I see Matthew just got the right answer, so do you want to explain it really quick?
It's just y2 minus y1 over x2 minus y1, x2 minus x1, which is -1 minus -2, which is -1 plus 2, which is 1, over x2, which is -4 minus 7, which is -11. So it's 1 over -11.
And yeah, that's it. And it's just from 7, -2 to 4, -4, -1. You take the change in the y over the change in the x. So it's -1 minus -2 is the change in y, which is 1. And then the change in x is -4 minus 7, which is -11. So it's 1 over -11. So it's -1 over 11. And yeah, that's the slope of the line. The slope is about like this. It's downwards, not very steep though. And yeah, we'll cover more of lines and more forms of lines next week. But yeah, that's all for this class. If you have any questions, you can just ask on Google Classroom or email. And yeah, have a nice weekend, everybody. This time the class is actually recorded, and I'll post that.